So we're going to take a look at the second expression that we have here. Alright, so again, you'll notice that you have a quadratic because we have x to the power of 2. But what do you notice about this particular quadratic? Beautiful, there are 4 terms, right? We have 4 terms rather than the typical 3 like these two. But this can still be factorized. Anybody wants to tell me what approach we may have to utilize so that we can completely factorize this? Lovely, the grouping method. Alright, so yes. I think I saw she messaged in the chat. Yes, she did. Yeah. Alright, I understand. So as usual, like I was saying, the resources, we are doing it now. I recorded on the whiteboard feed so they could get that. So she doesn't need to worry, she'll get it. Alright, but hopefully Teams stop playing up. Everybody having some issues these days. Okay, so before I continue, we just said we're doing factorization by grouping. For those of us who recall when we are doing complete factorization of a quadratic like question 3 or question 5 and even question 4, you all might be able to recall that we usually break up the middle term. So this particular quadratic expression we're looking at right now is just like that step we usually would take to break up the middle term and then move into the factorization by grouping. Alright, so now that like we said, we're going to use factorization by grouping, let's start off. Who wants to tell me what do we do to do the factorization by grouping? Okay, so you want to divide the expression into 2 parts. Alright, so tell me how we're doing that. Ah, nice. So we're looking at these 2 terms explicitly, these 2 terms explicitly. Alright, tell me what we're doing from here now. Lovely. Right, so we have a common factor of x between the first 2 terms because, like she said, we're using highest common factor method from here now. So go ahead. So we have x as our common factor. Lovely. Alright, so look at that. So this piece here is the completely factorized form of the first 2 terms. Alright, but we're not done yet because you have a full expression. So continue for us. Okay. Alright, lovely, because when you look at this, we have a coefficient of 7 and we have a constant here that's minus 14. Alright, now we'll talk about this sign in a little bit because in some cases, plus might not always be the case, but you want to factor out a 7, which is good. So we're factoring out the 7, and what next? Lovely. Alright, close bracket. So let's just pause for a second and just look at this. So although by default she just decided to maintain the positive sign over here, in some cases we know that when we factorize the second pair of terms completely, we need to pay attention to these signs, right? And in this case, between positive 7x and the minus 14, a common factor of positive 7 is possible. So that's why it worked out nicely for her, alright? So like I would encourage you all to do, especially for people who have trouble with signs, make sure that when you're doing your factorization, you factorize this first to ensure that the second binomial expression looks exactly like this one, the little shortcut sheet kind of thing. And then from there you'll ask yourself, well, okay, if I want to get back this x minus 2, what am I factoring out from these 2 terms to get back that expression? Alright, so here, like I said, it worked out really nicely. right? It was a positive 7 that was common between the positive 7x and minus 14. All right, and like I would always say, for people who have trouble with signs, try using the little shortcut. It will help you. You know your binomials have to be the same, and therefore write this down first so you'll remember that these two have to be the same, and then you could find out what is your common factor. So now what do we do here? Do we stop right here, or is there something else to do? All right, nice. So we do a complete factorization, right? So for some people, the shortcut always is, well, what is outside of the brackets goes into one bracket, and then you have the x minus 2, and you just write that back. And for those of us who need to understand what is transpiring here, remember, you're doing factorization, and just like how you could find a common term, a common factor, binomials are also common factors, alright? So you will notice that you have x minus 2 in both of these terms, alright? So here, your common factor is not just a monomial, a single term all by itself. In these cases, the common factor is a binomial. So that's why when you factorize completely, you can factor out this x minus 2. That's why this is here. This is a common factor, alright? And the other binomial factor, when we factor out an x minus 2, it's just like how we were doing the others before. You're asking yourself, well, okay, if I factor out x minus 2, what do I need to multiply x minus 2 by so I get back this term and then this term? So for people who the shortcut works just fine, you work with your shortcut. For people who need to understand that this is also a factorization step, you work with it the second way. Alright? Everybody has a different way they will understand information and process it, and you work with what works best for you. Okay? So this was our factorization by grouping. I don't, do I? Let's see what I'll do about that. Alright, so factorization by grouping.